You clicked because you want to talk about artificial intelligence and software development, but there is something far more dangerous happening beneath the surface of your codebase than simple bugs or syntax errors. The real problem is that AI accelerates writing while exponentially increasing the mental load required to verify what it has written, creating a productivity paradox where speed outpaces understanding. By the end of this video, you will understand how cognitive debt and intent debt are silently eroding your team's shared mental models and turning every engineer into a forensic auditor rather than a creator. For years, we have been told that generative artificial intelligence would be the ultimate force multiplier for software development, allowing us to write code faster and focus on higher-level architecture. The reality is more complex because while generation speed has skyrocketed, comprehension velocity has not kept pace. Margaret Ann Story's research establishes that this gap creates a specific type of liability known as cognitive debt, which represents the erosion of shared mental models within a team. When an AI generates code instantly without explaining its reasoning, it externalizes the work but transfers the burden to you for verification. You are now expected to validate logic you did not construct and understand intent that was never explicitly stated by your peers or yourself. This phenomenon is often called cognitive delegation rather than amplification because human reliance on these tools leads to a gradual atrophy of our own capabilities. We stop understanding the deep nuances of why we chose one algorithm over another, trusting instead that the machine has made the right choice based on patterns it recognizes in vast datasets. The result is a system where code executes correctly but fails to reflect the original business logic or architectural constraints because the developer cannot audit the AI's reasoning process. This creates what researchers call intent debt, a situation where the software works mechanically but loses its alignment with human goals over time as the rationale fades from memory and documentation. Quick resource note. I keep a curated set of Amazon search links in the description for books, gear, and tools relevant to this channel's topics. Some are affiliate links, so I may earn a commission at no extra cost to you. Please consider supporting the channel by using those links if you find something useful. Consider the scale of this issue through empirical data collected from over 300,000 commits authored by artificial intelligence systems. The findings reveal that approximately 15% of these AI-generated introductions contain defects right out of the gate, yet a staggering 22.7% persist long-term as unresolved maintenance costs. These are not simple typos or missing semicolons that compilers catch immediately. Instead, 89.3% of the introduced issues manifest as code smells and architectural inconsistencies that remain invisible to standard compilation checks but require significant mental effort to trace and resolve later in the development lifecycle. The primary failure mode here is rarely syntax errors because modern tools handle those well enough. The friction comes from the fact that we are shifting our role from writer of logic to verifier of opaque systems. When you paste a block of code generated by an AI, you must spend time reverse engineering its purpose before you can safely modify or extend it. This transition turns every engineer into a forensic auditor who spends more time diagnosing and understanding the system than actually building new features on top of it. The productivity paradox emerges because the velocity of generation exponentially outpaces the team's ability to verify logic, effectively creating a hidden liability where future maintenance becomes slower than the initial AI-assisted build. Think about your own recent experiences with code reviews or debugging sessions involving AI output. You likely found yourself asking questions like why this specific variable was chosen or what business rule justifies this particular conditional branch. These are not trivial queries. They represent a fundamental breakdown in communication between human intent and machine execution. The team's shared mental model, the collective understanding of how the system works that allows engineers to collaborate effectively without constant handholding, begins to fracture when code is generated by an external entity with no explicit rationale attached. This erosion happens silently because it does not produce immediate errors in your build pipeline or test suites. You can push hundreds of lines of AI-generated code and see green check marks everywhere, yet the underlying system state becomes increasingly opaque to the humans who wrote it. Over time, this leads to degenerate decision-making where teams avoid touching critical sections of their application because they no longer trust their own understanding of how those systems function. The capability atrophy sets in as developers rely on AI for everything from boilerplate logic to complex algorithmic choices, losing the intuitive grasp that comes from struggling through a problem and solving it yourself. The metric framework developed by DeSanti suggests we are currently operating in a zone where human-AI interactions have devolved into this state of cognitive delegation rather than true amplification. Instead of using AI to extend our capabilities, we use it to offload the thinking process entirely, which leaves us ill-equipped when things go wrong or require nuanced judgment that data-driven models cannot provide. The immediate bottleneck remains the resolution of tangible code defects alongside this abstract erosion of team understanding, but both are symptoms of a deeper structural issue where verification speed cannot match generation speed. We need to recognize that while AI introduces unique knowledge deficits regarding intent and rationale, we must also address the sheer volume of technical debt created by these tools before it becomes unmanageable. The cost is not just in time spent debugging, but in the cumulative loss of institutional knowledge that makes our systems brittle over months or years rather than weeks. If we continue to prioritize raw generation speed without establishing robust mechanisms for capturing intent and maintaining shared mental models, we risk building a future where software development slows down drastically because no one understands what they are looking at. The path forward requires a shift in how we approach AI-assisted programming, treating it less like an autocomplete tool and more like a collaborative partner that must be constantly audited for alignment with human goals. We need to prioritize documentation of intent alongside code generation, ensuring that every block of AI output includes the reasoning behind its structure, so future developers can pick up where the machine left off without losing their minds trying to decipher it. Only by acknowledging this cognitive debt as a first-class citizen in our development lifecycle can we hope to harness the true power of artificial intelligence without falling victim to its hidden costs. Thanks for watching all the way to the end. I am a one-person team working hard to make each video better than the last. Subscribe if you found value. It is the best way to show support. Drop a comment with your biggest takeaway. See you in the next video.